Hello, everybody, and welcome to yet another lesson online. It is lesson 6.10. Today's lesson is kind of a doozy, so we're going to get right into it. Please make sure that you have your lesson 10 template with you and follow along with everything that we do. It will get a little bit tough, but there's always time to clear up any misconceptions. Today's learning target is I can compare the lines and patterns generated by addition rules and multiplication rules. So today what we're going to do is we're going to look at some rules that are addition and some that are multiplication based, and we're going to see how the lines are different. Let's go ahead. Let's work on the side that has line P, B, C, and D on your paper. Okay, so all of these are going to be addition rules, just so you know. These are all addition lines and rules that we are following. And so we're going to work together and we're going to try and figure out what each rule is. Okay, let's begin. Line P, that's the very first one. The rule is y is 0 more than x. Let's go ahead and let's fill that in right now. 0, 5, 10, and 15. So our coordinates are 0, 0, 5, 5, 10, 10, and 15, 15. I'm going to go ahead and I'm going to plot those. Please plot those with me. 0, 0, 5, 5, 10, 10. That's there. And 15, 15. Now, lucky for everybody, I have just learned how to draw a straight line in this program. So there we go. And if I drew it right, then all of my points should end up on my line. And I did. So this is line P. I'm going to go ahead and label that line P. Let's take a look at line B. Now, we're remembering that this is an addition rule. So if x is 7 and y is 12, then that must mean that y is 5 more than x. So the rule is y is 5 more, please write this in with me, than x. And we can actually use that to go ahead and fill in the rest of our points. So I've got 7, 12. That means that I'm going to be 10, 15, 13 plus 5 is 18, and 18 plus 5 is 23. Let's plot those points. 7, 12, 10, 15, 13, 18, and finally 18, 23. I know I'm going pretty quick, so go ahead and pause if you need to. So let's plot this. 10, 15 is right there. 13, 18 is right here. And 18, 23, I think we're gonna go off because this is 22, so I'll put 23 somewhere up here. Let's go ahead and see if we have drawn a straight line, and that is correct. Nicely done. Okay, let's go ahead and look at 1C. So I'm going to change color. Now remember, we're doing addition rules. So if x is 8 and y is 18, then that must be y is 10 more than x. So we've got 2, 12. We've got 4, 14. And we've got 11, 21. And this one is going to be 8, 18. And go ahead and graph that on your paper. It should look like this. And here is my line. And our last rule, when x is 5. When x is 5, y is 2. So this is actually the first one that we're seeing where the y coordinate is getting smaller. So that means that our rule is y is 3 less than, Control Z, than x. So let's plot that. 5, 2. 7 minus 3 is 4. So 7, 4. 12 minus 3 is 9. So 12, 9. And 15, 12. If I plotted these right, they should all be in a line that is parallel. Let's see. And I can see here that all of these lines are parallel. What does this tell you about lines that follow an addition rule? I'm noticing that lines that follow an addition rule are all parallel and they all go in the same direction as y equals x. They just shift up and down. It's like taking this line and moving it up or down. Go ahead, turn your paper over. Let's see what happens when we take a look at multiplication rules. Now, this time we are all looking at multiplication rules. The first rule that we are going to look at is y is x times 3. So now we're shifting our work. We're now multiplying these by 3, and we're going to see, now you can see that line P here from last time is actually still here, and we're going to use that to compare and contrast an addition line to a multiplication line rule. Okay, when x is 1, 1 times 3 is 3, so our coordinate is going to be 1, 3. 2 times 3 is 6, so our coordinate is 2, 6. 5 times 3 is 15, so it's 5, 15. And 7 times 3 is 7, 21. Let's take a look and go ahead and plot that 1, 3, 2, 6, 5, 15. Let me scroll down and there we go. 5, 15 and 7, 21. If I did this right, they should still all go in a straight line. And they do. Okay, that is line G. Let's take a look at line H now. Okay, line H, it says y is 1/3 as much as x. So now this y value is going to be 1/3 of that. So 1/3 of 3. 1/3 times 3 is 3/3. So 1. Oops, let me go to green. So it's 3, 1. 1/3 of 6 is 2. So it's 6, 2. 1/3 of 12 is 4. So it's 12, 4. And 1/3 of 15 is 5. So it's it's 15, 5. Let's go ahead and plot those now. 3, 1, 6, 2, 12, 4, and 15, 5. And let's go ahead and plot that, and there it is. So what do you notice about our multiplication lines, and how do they connect to the y equals x line? I'm noticing that and I'm going to go back to problem number 1. I'm noticing that on the other side of our paper, we actually have all lines that go in the same direction, and these lines actually just shift up and down, and they're parallel. But what I'm noticing with multiplication lines is that they actually all pass through the origin, and instead of shifting up and down, they're still straight lines, but they actually just change the angle that they're going up. So the y equals x line goes straight up to the other corner. And if it's multiplying, it gets steep. And if it's multiplying by a fraction, it gets less steep. There you have it, the impacts of addition and multiplication rules on a line in a coordinate plane. So now you'll be able to see if a line goes up perfectly diagonally, it's an addition line. And if it is steep or shallow, it is probably a multiplication line. Thanks for tuning in, and I'll see you guys next time.